Hi, welcome to Main and 5W channel for yet another very interesting session. In today's session, I'm going to talk about quantum computer and computing, basically on what Microsoft is doing there. So, from my research for the last 2 3 months, I've really seen that there is something called Q Sharp. There is something which is released on the Azure platform. So, we'll see all of them in this session. Okay. So, before we start, I think for people who are very new to quantum computing, let me give you my point of view on what is quantum computing. See, basically, it operates on the rules of quantum mechanics. So you can Google search on quantum mechanics for superposition and entanglement. It actually helps you to solve tough challenges in certain computational problem much faster than the classic computing architectures. Okay, so how it differs from classical computing is quantum computing is all about exploring possibilities while solving computational problem. Classical computing explores only a subset of these possibilities. Okay, so quantum computer use quantum bits or qubits, which are a superposition that can exist in more than one state of 0 and 1, and you can create a 2 qubit quantum machine which allows you to do 4 calculation at once. You can create a 3 qubit quantum machine can do 8 calculations. Like that, you can actually do a lot of interesting things. So this capability enables quantum computers to solve certain type of complex problems and do parallel processing, which is not possible with conventional computers. So the power of qubits is that they can exponentially scale and speed up the computation. So you can have different type of quantum computers. I'm not covering that in detail here, but there are superconductor based quantum computer. There is quantum based on nuclear magnetic resonance. There is a gate model. There is a molecular magnet based model. There is an adiabatic quantum computers. Blah blah blah. Okay. There have been several OEMs which have really launched a lot of things. Like IBM has been working to develop a quantum for 35 years, and they have now launched 5 qubit, 20 qubit quantum computers. There are multinational companies such as JP Morgan, Honda, Samsung, and Barclays were the first to sign up for this testing of this device. Google has got a 72 qubit quantum processor called Bristle Cone. Okay, and then we're going to speak about Microsoft in this session. That there is D-Wave Systems, Intel, IonQ, Alibaba. So you can see that quantum computing is really going to be the future. It's used in a lot of use cases like optimization problems such as scheduling and route planning. It can be used for searching, sampling, pattern matching, encryption. It can be used in life science industry, logistic industry. It can also work along with machine learning. You can see that quantum computing process orders of huge magnitude more effectively than classic computing. It allows comparison of this with the AI thing. Okay, so the speed at which the world develops AI will go considerably with the power of quantum computers. What we see for detecting statistical anomalies, finding compressed model, training neural networks, blah blah blah. Just to take a use case in transportation, you can use something like mobility as a service. You can optimally distribute transportation capacities in a very dynamic urban systems where there are millions of transportation requests from people and for goods at short intervals, right? So there are a lot of challenges is there which we will cover up in the later sessions. There's no lack of good software, more QC algorithm that solve real world problems. It's basically more looking at research side at this point. Lack of collaboration is there, blah blah blah. So there are a lot of plus and minus to it. So it was a very quick overview about what the quantum computer is. But in today's session, I think I'll only cover Microsoft's strategy on this. The first thing which I want to speak about is you have something called Quantum Development Kit. Now, Microsoft has open sourced this QDK on the GitHub. Okay, and it is inviting developers to contribute to its development to unlock the power of quantum computing. Okay, so what QDK involves is it involves something called the Q sharp. Like we all have heard about C sharp. Similar to that, you have Q sharp, which is quantum programming language, and a compiler. There are lots some samples and tutorials. You can get started with quantum computers. It has simulators, resource estimators for quantum programs, It also include development environment extension for VS and VS Code, and it also integrates with the Jupyter platform. Okay, so what it is trying to do here, by doing it open source, is encouraging developers to contribute to the quantum app and algorithm, and also as well as advancement in compilation, optimization, blah blah blah. Okay, so what Microsoft is aiming from a content development, I think we will go through the other vendors in subsequent session, is to develop and deploy the world's most scalable, secure quantum computing system to support a rich ecosystem of domain experts, developers, and researchers to solve today's most challenging problems. So that's the vision. So by open sourcing, they're trying to encourage a lot of developers into this technology. Now let's see some of the on the website how they really look like. So if you really go into quantum development kit site, so you can see that it talks about experience the impact of quantum solutions today. We are bringing quantum apps to life with an easy to use tool set, deep integration with leading development environment, and you can set up the QDK here, and it provides you a Q Sharp, which is a new high-level quantum-focused programming language, rich integration with Visual Studio Code, interoperability with the Python programming language, enterprise-grade development to provide fastest on Windows, Mac OS, and Linux. Okay. So it also gives you a code optimization in a simulated environment, set breakpoints, steps into Q-sharp code, debug line by line, estimate the real world cost to run your application. You can simulate the quantums requiring up to 30 qubits with the local simulator. Okay. You can also do something like an open source library and samples. It's developed by top industry experts. Collection of ready to use building blocks take you from being a beginner to building your first quantum solutions. You can have open source development libraries, blah, blah, blah. And there is also an introduction to Azure Quantum, which we know like Azure is the cloud solutions, is a cloud platform for quantum computing. Developer use a QDK to build Q-Short program to run on the quantum hardware or formulate problems to run on the quantum inspired solvers in the cloud. So the concept is very simple. As a developer, you write your code in your IDE, and then you build that, and finally you have a cloud infrastructure to host it. You can also see here that something called Azure Quantum is now, the QDK is now connected to the Azure, bringing limitless scale. You can see at the bottom part you have the quantum hardware, which is the Microsoft thing, and you also have a third party like Honeywell. Then there is a classical hardware, which is basically Microsoft Azure for future ready systems, and there is a quantum hardware. On the top of it, you have this development tools like Q Sharp, QDK, Microsoft One Qubit, simulators, and the top you have all these applications what you want to use it for. Okay, so quantum katas is a very interesting thing to help learn quantum computing with series of self-paced tutorials, sample demos. So you can go through all these things. There is an open source QDK you can also download. So that's the very interesting part of quantum computing. See, one, that's it exists as a theory. Number two, it has got a QDK. You have a language. Number three, you can connect it to the Azure and then start developing solutions. Okay. How to set up that? Content development is pretty simple. I just thought I'll just run you through the Q-Sharp programming language, set of libraries. You install the QDK locally, use the QDK online, use a QDK Docker image. Okay, these are three ways. So you can develop Q-Sharp code in most of your favorite IDEs. So you can actually use your VS Code, VS install Jupyter or command line, and you can have it run it with Python with .NET. Okay, then you can use the QDK with the Docker, basically on the Docker image in your local Docker installation, or in the cloud or via any service. So that is how you can set it up. Okay, you can also see the open source quantum, which we spoke about, that Microsoft open sources its quantum development kit. If you go to GitHub, you can find that the Microsoft quantum development kit is available along with samples with some examples which you can really look at. Okay, so this is a brief about Microsoft quantum computer vision and what are the various things. So hope you found it interesting. You can jump in as usual as a developer, which have been in .NET and C Sharp, also working with Microsoft for some time in terms of developing codes. I think this will be a very interesting journey for developers and architects to re-architect programs for the future. Thanks for watching.